It's a big day for you. Are we ready, guys, or you need a minute? Ready. Okay, if I'm asking you to find the equation of a tangent line, guys, this is part of what's hard in this skill is knowing what I'm actually asking you to do. It doesn't always just say find the derivative. Now sometimes it will and you know exactly what it is. But this, you have to understand that, okay, if I'm writing the equation of a line, I need a point and I need a slope. You have some of the point here. I gave you 1. How do we find the y coordinate of that point?
Plug it in.
Plug it in, and what do I get when I plug it in? 7. Okay, so there's your point. How do I find slope? I do take the derivative. Okay, so f prime of x. What do we get? Okay. Okay, that works. Everybody okay with that? So the slope I need is f prime of 1. Yep. Okay. Okay, that's the slope then. Okay, yeah, and that's really like a big part of it. So this graph, I don't know what it looks like because it's parabola and the square root all together. I can't visualize that very well. But what this is saying is, you know, whatever the curve is, whatever that shape is, if I go to the x value of 1 and draw the tangent line there, it will have a positive slope of 8. That's what that means. Okay? So then your final answer should have been y minus 7 equals 8 times x minus 1. Stop there, guys. Because if you go farther and you mess it up, then I have to be mean and take points away from you.
Or
so just stop.
It'd be like a really nice.
The AP readers will not be really nice to you next year. So.
Just take it if you freak out. Wait, how do you see the derivative of 4 over
That's 4 root x, right? 4x to the 1/2. So 4 times 1/2 is 2. X to the negative 1/2 is over. What's your Which part of it don't you see?
No, I got 2 times x to the negative 1/2.
Well, you can plug it in that way. That's fine. If I ask you just to find the derivative, I usually say without negative exponents. So then you'd have to be able to simplify that. Negative exponent, remember, means to move to the denominator. All right, guys. Notes time. We're jumping in.
Yes.
I
agree. Why do you
All right, guys, we're doing the chain rule today. Chain rule. It's a good time, guys.
Well,
Yeah, I'm teaching it today, whether you want to do it or not. So, Ben? If what? I'm sorry. Negative exponent. Yes. And then it's no longer negative once you move it. All right, guys. So the chain rule. Let's write the formal definition, and then I'll show you how to use it. So if f of x and g of x are both differentiable functions. What does that word mean, guys? Differentiable. You can take the derivative of it. That's, yeah, okay. Derivatable. I can't even say that. Derivatable. Yeah, there you go. And h of x equals f of g of x. Then differentiable. I left out an R. Differentiable.
Is there an
We just abbreviate it diff, guys. Differentiable. Okay. Sorry, guys. Sometimes spelling and talking doesn't go well. All right, this will equal f prime of g of x times g prime of x. Okay, I know that looks scary. I will show you and you will understand, I promise. Horrifying. Nate's like, okay. Maddie. Maddie's mad that I don't have a cool fist bump figured out for her yet. So you have a lot of them. Guess what? I have a new lesson for you every single time. It is. Yeah, that's time. You what?
Oh my god.
Never a dull moment, guys. Oh no, your pen's dying. Does that make your head hurt? You okay? Okay. You've moved on from stat. You're ready? No? Okay. Oh, that was a quick no.
I'm so ready for this.
No.
I love stat so much. I had my highest grade is at class.
What? Wait, what do you read? Like, this is all. Wow.
All right, guys, let's try one.
That's just it.
That's it. We're going to find the derivative of this. I know I wrote you no directions. I just wrote an h of x.
Take me one anyway. Just figure it
Read
out.
my mind, guys. Come on.
You're gonna do this, right?
Yes, I'm going to do this.
Okay.
Okay, so up to this point, if you saw that, you'd go, okay, well, I guess I could multiply it out and then use the power rule, right? I don't think anybody wants to multiply that out. And what if the exponent becomes like a 9? Then do you want to multiply it out? Nope. Okay. So chain rule, let me just show you how it works. And then I can also show you like the breakdown of what f of x and g of x are in this thing. So with chain rule, you sort of start on the outside and work your way in. If I saw just x cubed, what would you tell me the derivative is? 3x squared. Okay, so 3, leave this thing in the middle alone, and then squared. Do you see how we did kind of the outside derivative? We dealt with that exponent on the outside. The inside stayed the same, right? Okay. Now we keep just working our way in. Now we're going to take the derivative of the inside, and that's this times g prime of x part. So we're going to multiply by what is the derivative of the inside part? Negative 2x. Okay, so my final answer, the things I can actually multiply are the ones without the exponent. So I could take 3 times negative 2x and say negative 6x. And then in parentheses, 4 minus x squared squared. And that is it. You do not need to be multiplying that out. You should stop there. Okay?
And this is the correct.
That is, I mean, really, yes. We'll practice a bunch of them, but that is the chain rule. Yeah, we'll do a few more, but the ideas are done.
Why don't you squared out?
Because I don't want to.
You don't want to.
Because what if you finish and it's, what if it was a 9? You'd have,
Not good.
yeah, right? So no, this is fine. Stop here. Yeah. Leaving it in factored form is acceptable. It's what we want. So if you want to see like this part of it, what I was talking about with f of g of x, all of that, you can think about g of x being the inside part, being that 4 minus x squared. F of x then is essentially x cubed. Right? Do you see it? If I did f of g of x, I'd get... I think you actually just understand what's happening on the left though, right? Okay, yeah. I don't think you need to think about pulling out what is f of x and g of x. I think that's harder. So, all right, let's try again. I see. All right, quantity 4x plus 5 to the 3/2. Anybody want to multiply that one out?
Nope.
Nope. All right, you guys try. You do the thingy. Yep. Check someone around you. Do you agree?
Multiply by
It's easy to miss that last one.
Yes, I turned in my mentor application contracting 2 days later. I was like, I'm sorry, I accidentally sent it as a draft, and they accepted it, they didn't reject it.
Yay!
I just didn't want to do it. To be honest, I just You're so right for that.
Yeah, because that, like, yeah, probably not. I went to some, it's almost number one. I don't know what it is. You never learned that.
All right, guys, I would take either of those answers. Yay? What? You're a nerd if you do the second one. What's wrong with being a nerd?
What? Oh my god.
Anybody questions on that one?
You get consideration.
Thanks. Let me write the next one while Hey guys, we only have 5 examples today, okay?
Oh my god, are you serious? I didn't bring my switch.
It's okay, I'll just write Star Rail while you're...
Alright, try this one, guys.
Mentally prepare yourself for it.
I'm gonna take a nap is what actually we're planning.
It was good for you. I'm not doing
He hasn't been here for so
I think he's accepted.
What about it?
No, those are the 2 points.
Oh yeah, either one of those.
I'm gonna do the reflection.
Ava will brand you as a nerd if you use one of
Of
them.
course I am.
Yeah, so, I mean, it's only simple enough, like, transform.
Sure, go ahead. Because you're presenting your now.
You took that extra step, but yeah,
Yeah, you really, like,
you really like radical.
overachiever.
So,
Correct, guys. No negative exponents in your answer, okay?
yeah, so.
Come on.
I realize
Come on.
this square root is one half exponent.
Yes. You should. That is what I would do.
Okay.
You have fun with that. No, you're right.
No, it's this.
That also right, but that you're right.
No negative exponents in your answers. I don't care if you write it with a radical or with the fraction exponent. Either way's fine. And guys, you don't have to rationalize. Okay, just no negative exponents.
Oh, that wasn't a plan. That wasn't...
Yeah, you're like, oh, rationalize.
Right, no, we're not.
I think I lose this one.
What?
Just kidding.
You can do it.
I'm shooting again.
Only 2 more examples.
I don't lose this.
We're going by one for
You don't have the rationalize, right?
No rationalize.
the reason again, and I'm doing it to my point theory. My theory could not care less.
We'll set up chairs in a little row and do a little gallery.
Or we're doing a
And then I
gallery
check you up. No, like, we'll just have them sit. We talked about that as an option, but I don't.
Do we have to actually get on with this? So I'm trying to do it myself. And we're going to see how everyone does.
Okay.
We're going to see how everyone can guess something.
I like that.
When do I pause it?
Who knows? I don't even know.
What do I usually eat for breakfast?
All right, guys, let's go through this one. Step 1, rewrite it with the fractional exponent. I think we're all okay with that. So h prime of x. Guys, up here.
Oh my god.
Start on the outside.
A banana?
Work your way in.
What? Yep, got that. Okay.
Let it.
Yay!
Wonderful.
Oh my god, got it. That is great.
Non-nerd. Yeah.
Which one's the word answer?
Nerd is with the square root in it.
Yes.
The one I wrote
Was
first.
it the nerd again?
Clearly.
No.
Questions, guys? Are we catching on to how chain rule works? Just piece by piece, work your way in. This is prep. All right. Good. I'm going to combine it with your quotient rule now.
Pardon me? My quotient. Sorry, my what now?
And guys, everyone okay with it doesn't matter what function letter it is, f of x, h of x, g of x, c of x, whatever.
All over t squared.
That's so
Good
fun.
job. I think so.
Wait a minute.
Last one.
It was like later and subtracted it and then like, you know.
Low D high minus high low for that.
I don't like this.
No.
High.
I think I understand, possibly.
Denominator times derivative of numerator minus numerator times derivative of denominator. Yep, quotient rule, and then you'll have to use chain rule within your quotient rule. Okay? Yeah. Because when you look at that denominator, derivative of the denominator, chain rule, right?
Low D high and minus high.
That's the second part, yeah. I'll give you a minute.
Are
on
you
this.
serious?
got
What
this,
is this?
We can do
This is
it.
actually
I
so.
was like it, so.
Who? Why? This is so evil. God, I gotta multiply all this out. Are you serious?
It's pretty funny.
Are you
You
kidding?
don't have to multiply everything out. Leave the like x squared minus 3 factor thing there.
Oh, okay.
There is some like simplifying that can be done in this one, okay? This is where you guys tend to get creative with your simplifying.
Oh, is that what we're
creative.
calling it?
Yep, that's what we're going with. Positive spin.
Positive spin of us not knowing what to do, so we just keep going.
Mm-hmm.
Yep.
Just get happy crossing things out.
And then is it over like the denominators?
Yeah, so denominator squared, that'd be that thing to the.
Oh.
This is so fun. So glad.
What a great Monday,
This
guys.
is such a fun Monday.
You should just rename it Fun Day.
Oh my god, what am I doing?
You got it, Will. Well, you got something, right?
I have it.
You have an answer. Okay.
It's another question.
Debatable.
I have something.
Okay.
I have very long things going on. I don't know what to do with it. What am I doing? How?
Well, when you're taking the derivative of the denominator, that's when you're going to use the chain.
How long should it be?
So, yeah. Maybe. Okay. I'll give you a few more minutes, guys. I will in a minute. Yeah. Five. The last one's not quite as long as this. Mm-mm. You're gonna end up factoring things out. I'll show you.
What do you mean we're fast? Where?
Can your brain wrap itself around the simplifying without breaking any rules?
I don't even know what the rules are.
Well, you do the quotient rule.
Oh,
okay.
That's so annoying.
No, not until you need that part in the quotient rule. Anytime you're taking the derivative of like a fraction like this, think if it was one like you've done before. I don't know. For like, right? You wouldn't just go 3 over 2x. Like, that's not how that derivative would work. You'd be like, low times derivative of top minus top times derivative of low.
I mean, why is it once you have
An example.
I was just making up a new basic
okay.
quotient rule.
Oh.
That's definitely not correct. Besides the point. We tried.
I'm gonna write step 1 and then I'll stop. Okay.
Yeah, good.
I'm here. That's a lot.
Wait, why do you have two X's?
Alright,
Quotient rule. So you're good with this part, right? Okay. Top 2x. Okay. Times the derivative of the denominator. That 2 is there.
Yeah.
X squared minus 3 to the first.
Yeah.
And then with chain rule, what else would I multiply by?
Oh.
Inside. Okay. This is not your final answer.
Wait, so what is it? That's horrifying. Oh wait, I didn't see the like you draw it for the denominator. Or are we leaving that as in the parentheses?
The x squared minus 3. Did you like multiply that out? Leave it factored. Something's actually going to cancel out here in a minute, but
Wait, can I set, I found like 2 in the numerator. Square minus 3 factored out or 78?
let me show you the next step. Then
Where did you get that answer?
chain rule. If I'm taking the derivative of just the denominator, what would you do?
2 times again, x squared minus
I need the chain rule. This is the
2x, right? That's
you not multiplying for the denominator and for just denominator.
I use chain rule wherever I need chain rule. The only place I need it in this one is when I'm taking the derivative of the denominator.
Why wouldn't it be in the numerator? Well, because it's one piece.
Yeah, there's no parts. There's nothing to an exponent, like some big quantity to an exponent. Okay. All right. So let me just rewrite this a little. I'm bringing that 2 to the front. Okay. 2x times 2 times 2x. I can actually multiply that all out, right? Thanks. Okay. Do we get that? Okay. With me there. All right. Yes, I could factor a 2 out of the numerator, but that's not really going to do anything. Do you see that I could factor out an x squared minus 3?
Yeah.
Because they both have that. Okay. Pause after this step. And then I think you'll see what's happening. Bless you.
What happened with minus? It was the 8.
Okay. All right. Do you see that this is going to cancel one of those out? Okay. Let's go ahead and simplify the numerator a little more also. That could be 2x squared minus 6 minus, sorry, 8x squared. Denominator is just x squared minus 3 cubed. So what do you think our final?
6x squared. Negative 6 squared. Can you do this 6 like that, or do you have to factor it out?
I would completely take this or factor out a negative 6, make it x squared 1. Like that's, either of those are fine. Okay. Can you see it? Okay. Let's make sure everybody's caught up. It's a lot of simplifying. It is.
Oh my god.
It's product rule instead of quotient rules.
Just like in hot water, like
Yeah, but you might want to like do a quick run first and then pour it out.
How does it work? It's like,
All right, are we ready for the last one, guys? 1 second? Okay, well, wait a second. Nate, you good? Jane's good? Okay, Nate looks like the process.
That's crazy. Hey, it's not okay that you don't match this, okay? All us is like that. Because like
You good, Nate?
yeah.
Are you sure? Do you need a minute? Okay. All right, one more, guys.
In your case, it's a little bit. It's not like the only thing on your mind. It's not like something. It's not like that. Sure, it's not like that.
All right, guys, last one.
Oh wow.
Do not multiply this out, okay? Product rule, yes, not multiply it out and use power rule, is what I'm saying. Yes. Very good, Ada. Product rule, chain rule will come up.
Why is there a lot of x squared in the
I don't know, we did have a lot of x squared and 3s. That wasn't that bad, right? What? It's like if it's f of x times g of x, like those are your two functions. It's g of x times f prime plus f of x times g.
Okay,
Yeah, you remember?
Cosine, yeah, sine, cosine, not lovely.
I don't know where I got the place.
Yeah.
Got it?
What does it leave it like?
There's a little bit of weird factoring that I'll show you guys in this one, but if you're,
Weird factor.
I mean weird factoring.
That's not like a 4
Uh-huh. And what else?
and 4x
Four.
squared. Oh.
I'll show you. I'll give you a minute.
This is horrid.
Guys, do you see what I mean when we get into calculus? Like, the calculus part is not that hard, right? Is this derivative piece that hard, or is it the simplifying and the algebraic stuff that, like, you get tripped up on?
Absolutely the algebraic stuff.
Yeah.
I'm dying.
You're dying in the algebra. Yeah.
I thought I figured it out.
Yeah, you.
So the reason being, this could be a multiple choice question. You'd have to be able to recognize, like, oh, that's what they simplified it to. So
4x squared
Aiden is right.
Yeah, like I've done this to like count, I just got a 4.
I should see it.
What is going on, man? No,
You did.
There's the other four in the background. I'm not even, it's not there. I don't know what I'm doing.
Here, let me write the first step. Make sure we've got the derivative part down.
Why do I have to put the third? No, I saw it. That's bad.
No, take out one.
I'm there. I think I got it.
Okay.
Wait, 8. So did you multiply that?
Yes.
Oh!
I'm just doing the first couple steps.
Doing.
I'm gonna blissfully ignore it and come back.
That was so unnecessary.
Stop here.
We got it.
Were you guys okay with step 1?
Yeah.
We got our product rule down?
I understand where I messed up.
Okay. Maddie, what? Eight instead of. So when I do this one here times this derivative, chain rule on this one. So the 2 comes in front, this to the first, then times the derivative of the inside. Don't forget that part of the chain. Do you see it? With condition, so it doesn't like really matter. It's like, but, yeah. Like all of this? No. Let me show you something. So I look at it as this guy was f of x and this guy was g of x. And so my derivative, I did g of x times f prime plus f of x times g. Yeah. What are you asking?
Am I not supposed to do 2 times 8x minus 1?
Hold on, let me answer Maddie's question. What? I take f times g prime. That for me happened over here. And I take g times f prime. That for me happened right here. You do both. Yeah. Okay, guys, from here, do not multiply everything out. We are going to we're going to factor. 2 by 8x. Don't do that. All right, I see, here's what I see for common factors, guys. I can factor a 4 out of both of those, right? Okay. Then I can also factor an x squared plus 3 out of both of those. Yes? Okay. So, out front, I will have a 4. And I will have an x squared plus 3. Left over from this first part, I have an x and an 8x minus 1. Plus, do you guys see how I'd have a 2 and an x squared plus 3?
Yeah.
Yes.
So, like,
We're going to simplify that.
I just you guys.
Okay. I'm going to just kind of squeeze it in here because I don't want a whole new step. So that's 8x squared minus x plus 2x squared plus 6, right? So my final answer, I will have 4 times x squared plus 3. And then what's left in here? Well, when I simplify this, won't I get 10x squared? Yeah.
Oh, so you are.
Yes, simplify within that parenthesis, okay? That's your answer. Please don't multiply that all out.
Wasn't 32x to the fourth.
It would be 40x to the fourth.
Oh,
We have another 8x squared in there somewhere that you missed.
yeah, probably. Squared.
So this is right? G
That's the chain rule, yes.
Yeah. So then, if you're multiplying it by the derivative of this, wouldn't it be the derivative of g of x?
So the derivative of f of x, you don't even look at g. These are two separate rules going on at once. This g of x is not that g of x. Does that make sense?
Yeah.
Okay.
Makes sense.
All right. Okay, guys, question. Whizzes. Partner up, guys. No. It's 10 questions. You can do it. Some of them you'll want scratch paper. A lot of them you could probably do it.
No. This is a challenge. This is how I learn. Is the light
Oh, for sure.
Bro, you trying to like
Who needs it? Same, bro. What?
All right, guys, 3 of you made it in. We're a little slow this morning.